Okay, here we are comparing the L1 and L2 regularization for both logistic regression and neural network. So let's use a diagram to compare them. Suppose there are two weights, W1 and W2, and suppose our cost function is decreasing in, say, that direction. So this is cost, this is decreasing, say, this is 5 cost, this is 4, this is 3, and so on. So it's basically decreasing in the direction of this arrow. And we are comparing, first is models with one norm being equal to 1. What that means is basically W1 plus W2 absolute value is equal to 1. So if you want to draw it on the diagram here, it means all the models with W and W2 with this shape. So this is 1 here. So if we want to find the best model among these, then we just increase the cost until we hit the boundary, say here. If we move a bit further, we'll not touch these models. So this is the furthest we can go. So this cost is the maximum or minimum cost we can reach. So this is the best model if we force the one norm to be 1 here. We'll do the same thing for the 2 norm, which means W1 squared plus W2 squared is equal to 1. So you can see this is a circle in the diagram. So every model along the circle will be having 2 norm being 1. So if you use the same cost, then you know that this is not the optimal model because you can actually move further and get here. So now here at this point, this is the best model among the models with 2 norm being 1. So you can have different cost structures. For example, if your cost is like this, then you can see that this is the best for L1, and let's find something here will be the best for L2. So what you can see here is that with L1 regularization, we have either W1 is equal to 0 or W2 is equal to 0. It's very difficult to get anything in between except for cost increase exactly with this slope. So that's what happens most of the time. For L2 regularization, except for if it's vertical or horizontal, the cost go those directions, all other directions, W1 is approximately 0, it will not be exactly 0, or W2 will be approximately 0. So what that means is with L1 regularization, we can actually use it to select features because when the weight is 0, it means this feature is not useful in the prediction. So L1 norm can be used to select which features have 0 weight, which means which features are not useful. But with L2 norm, it's more difficult because there will be many that's approximately 0, but none of them is exactly 0.